Okay, hi and welcome to Djinni in a Bottle. My name is Stephan Jaetzold and I'm a freelancer making iOS apps, but I also have a long history of doing Java work, so naturally I'm interested in ways of making the two work together. Recently I worked at Dropbox and there I came across an interesting and powerful technology with a tool called Djinni. And in this session I'll show you how to use Djinni to easily share C++ code between iOS and Android. So I'll mainly do that with a demo where I'll be setting up and implementing a small cross-platform app from scratch. But before that, I'll briefly talk about what Djinni is and where it fits in, and afterwards, of course, a summary, and I'll mention some aspects of Djinni that weren't covered during the demo. So what is Djinni? Its GitHub repo states, Djinni is a tool for generating cross-language type declarations and interface bindings. But what does this mean exactly? So Djinni consists of a pretty simple interface definition language where you describe your types and interfaces in. And then it generates C++, Java, and Objective-C code out of that. But it also takes care of all the code in between, like what functions to call and translating the types to an appropriate representation in the other language. So in the end, with Djinni, you're only dealing with Java code and its types on the Android side, with C++ code and its types on the C++ side, and Objective-C and Foundation types in the iOS world. And it's open source, so there's no vendor lock-in to fear here. So the idea of Djinni is not that you implement your whole app cross-platform. You'll implement the UI still separately for each platform because the platforms are different after all. They each have their own established user interface patterns to follow, and you want that to have a really polished app. But also many apps have a big part that's business logic, that's dealing with data, and that you want to be the same across platforms. And with Djinni, you implement this business logic part cross-platform in C++. Your UI you implement in Java or Objective-C with the platform native toolkit, and Djinni takes care of the connection between the two. But yeah, this is a tools in action talk, so with that, I'm going to demo how to set Djinni up and use it. I'm going to not really clone, but copy the GitHub repo locally so that I'm not dependent on the network connection. And then we'll make an IDL file called greeting.djinni. And in that, we define a small service, a greeting service that generates greetings for us. And notice the little +C behind interface. That means we're implementing this interface in C++. So generating the code, the Djinni command for that, takes a lot of parameters. So I'm also adding a shell script here. As you see, a lot of parameters, and I don't want to remember them all. They control where the source code is placed, what package the Java classes are in, how the names are generated, and things like that. And with that, I can run the script, and it generates the code for us. That was pretty quick. Usually, if you clone the repo, it fetches dependencies first and compiles itself. Djinni itself is implemented in Scala. But because I copied the directory, that was already there. So let's have a look at what it generated. So it generated a header in C++, and that we're going to implement ourselves. So make a directory for our C++ implementation. Then it also has a Java class, an Objective-C class, and then the glue code in Objective-C++ and Jni. So now I'm going to create an Android project that we call Android client. And we, of course, want to include C++ support. Oh, wrong path here. Okay. Yeah, that's all fine. We can do with the defaults. We want C++ 11. Exception support and runtime type information is important for Djinni too. So it generates the right compiler flags for us already. And also for code sharing, you want to use the same code for both apps, like the actual same files. Usually, you probably want to set it up that your Djinni and C++ code lives in a separate library project, for example, that you depend on. But for this demo, I'm just going to create some symlinks. That puts all the directories that we use for Djinni into our Android project, so we can use them there. So let's see what it generated for us and where I put it in the project. So here is a directory for the generated code, the IDL file, and support library. That's code that's part of the Djinni distribution. That's the generated files use. And here is our C++ code. And now I'm creating the implementation of our greeting service. Let's call it greeting service impl with the header. And I just paste in the code there. It's still red because we haven't told the build system yet where our C++ files live. I'm going to add the implementation code as well first. And then we'll edit CMake lists, which is where we specify where all our C++ code lives and how to package it up as a library. So I'm telling it where the support directories are, what directories our generated code and our implementation lives in. And also I'm defining a shared library here, which we'll later include in Java. But because it also generated an actual Java class for us, we also need to add something to our source sets so that the build system finds that generated Java code. Let's sync that. And then the C++ and header file should get green after a while. Okay, still running. Yeah, so it's done now. So let's see. Yeah, everything looks fine here. So now in the main activity, I can leave native lib as is there because I've named it the same. And we can use the greeting service just as any other Java class here. And just when we fetch a reference to it, like when we create the service for the first time, we need to bootstrap the connection between Java and C++. So we're not doing a new here. Instead, we're calling the static method that was defined there, which gets you the first reference into the C++ code. And then we can use that greeting service to generate the actual greeting. Okay, this was auto-generated for us. We don't need that. And also, so that it just looks nicer, I'm going to modify the label a bit. Increase the font size. Center it. And move it down. And then we'll build that and run it in our emulator. Okay. So I just want to point out that you're really using a Java string here and a Java class. And you're not seeing that this is implemented in C++, except for that you need to load the library, the shared library somewhere. And in C++, you also just are dealing with standard C++ strings and shared pointer and all of this, and you're also not seeing that this is actually used from Java. So everything gets translated for you automatically. So this should start up pretty soon now. And there, yeah, like the standard first demo app. Now let's go ahead and do the same for iOS. A new project there. Yes, standard is fine. Yes. Okay, and there we need to also add our Djinni code, like this, and the C++ implementation we just did. So adding the IDL and our C++ implementation. We can add it to the target. We don't want to copy it because we actually want to reference the same files. And let's organize this a bit with a group. And there I import the generated code and the support library. The support library is in the Djinni distribution. Is that everything? Yeah. Okay, I don't add it to a target yet, because the support library and the generated code also contains Djinni implementations, for example, which I don't want to compile for iOS. But now I need to modify the target myself. So I add the implementations from the support library. And then in the generated code, we have the Objective-C implementation I want. And then for Objective-C, only a header, and here as well. So it actually is enough to add this to the target. Okay, and because our service is already implemented up here, we can go ahead and use it right away in our view controller. And now in Objective-C, it also just feels native to the environment. I have a greeting service that's prefixed in Objective-C because that's how you namespace there. And I'm going to initialize it the same way, pretty much, as I did it in Java, which is calling the class method on it. There was no label auto-generated for us, so I need to do that manually here. And now I can assign the result to the text property. And again here, now I'm creating an NSString literal, so everything as it should be in the iOS world. Now the label needs to be set up a little bit so that it actually appears in our view that I prepared. Okay, so that's it for iOS, and we can run this as well in the simulator, this one. Okay. So now I'm going to extend that greeting service a bit to show you a few more features of Djinni. So Djinni supports more types than string, of course, out of the box. Like we have a few collection types, a list. So I'm going to change this parameter so we provide a list of people we want to greet. And you also have set and map, which get mapped to the appropriate types in each language. And now I don't return anything from greet anymore. Instead, I will add a display reference to that service. And this will also be a Djinni interface, but this time it will be implemented in Java and in Objective-C. So this is how you can add callbacks then. So you go into the C++ code and back to Java or Objective-C and can do round trips as much as you like. And this can display greetings. And this greeting will be another type that Djinni supports with this, which is a record. And records are value types. So before, you actually get references to the object in the other language. With the value type, you get copies of your data. And this greeting, of course, contains a message, which is a string. And just to show off a few more features, it also has a color. And this color will be an enum. And yeah, greetings can be either red or blue. And more things, apart from more types like Boolean, various types of integers, floating point and such, you can also define constants here. So let's define a constant that is a cooldown. And that's a very long integer. And we can set that value right here to, let's say, 4,000. But maybe it's not really obvious what it does or what it's for. So let's add a comment here. But now, so this cooldown like slows down generating greetings a little bit. But that means that our greet method now can take a long time. So I also add a comment there that it should be called from a background thread. And I want to mention here that it's better to not create new threads on the C++ side, instead use the native platform to do that, because that might get you into trouble. It doesn't interoperate well with the actual platform you're on. And the Djinni distribution contains example code that uses Djinni to implement an interface in which C++ calls to get a thread from the native platform. But here we're just calling it right away. So let's generate the code from this. And then implement this extended service. So now that method is not valid anymore. So I'm going to add the extended version of it. And also here. Oh yeah, actually, in Xcode, or app code in this case, so with Xcode projects, we need to add the files manually, the newly generated ones. This is also a reason why you might want to put that into a separate project, because then you can auto-generate the project file if it's only for the Djinni code. Add those. last ones we need for the Objective-C side. So it generates one file for every type you define. Okay, so now I already did the implementation here. So it changed, so it gets in a pointer to the greeting display. The list gets translated to a vector in C++, and this is just a reference to the display. And in the implementation, I'm just generating the color randomly and creating that greeting object in the standard C++ way. Okay, let's update our view controller so that it uses the extended greeting service. So here we now pass in a reference. The greeting display is created as a protocol, so we can adopt that here and actually import it so that it knows about the method in there. So let's implement that. So this greeting now has a message property, which we can use to update the text in the label. And it also has the color property, which is an enum. So that means we can do a switch over it. And just label text color. Okay. And just so that it looks nicer, I let the label fade out. And here I'm using the constant that we defined. And so you see how it looks if you're using that in Objective-C. But also how we call into the service changed a bit. So it doesn't return a result anymore, and it takes an NS array as a parameter, an array of strings. And also, yeah, I can show the comment here actually. So it says call from a background thread, so we actually do that. Call this in another thread. But this also means that when the callback comes back here to the greeting display, we need to switch back to the main thread. Oops. Wrong one. This one. Okay. So let's run this in the simulator. Okay, there we have our text. It has a color, fades out, changes. Now we get a blue one. Yeah. And so let's do the same in Android this time with the implementation already there. We need to refresh it a bit first. Okay, so it recognized that already. But also Android needs a little bit of extra help. So it didn't recognize the newly generated CPP file. And for that, you want to do refresh linked C++ projects up there in your build menu. So let's go to the main activity and add the parameter, the greeting display, to the create service method. But since we are on the Java side, we're not doing any protocol things here, we can actually use an inner class and then forward this call to an actual implementation in our main activity. Let's be final then. And this we can create. And since this is the same code pretty much as on the Objective-C side, I'm just pasting it in. So again, it gets the message string there, sets it, gets the color, can do a switch over it. And here is the constant. This is how it looks on the Java side. Also, we need to change the way how we call into the greeting service, which is also pretty much the same. And also, we need to switch to the UI thread here, which is this one. Okay, this needs to be final as well. And now we can run this in the Android emulator. Yeah, so this is not the fastest machine. And one thing which is a drawback if you're using C++, your compile times increase. And there are also some optimizations which you usually can use while doing Android development that don't work if you also have C++ code that you're compiling with it. But let's see what it does once it's finished. And there, yeah, same thing, just on Android. Okay, so let's summarize. So Djinni gives you an easy, transparent bridge between C++, Java, and Objective-C. It supports many basic types already. But if you need more, like your library or app has specific types it wants to support, you can add that as well. So there's a possibility to define types you can use in Djinni, which are actually implemented outside of Djinni. And for example, PSPDFKit, which uses Djinni, uses that capability to define its own mapping of a caller type. Also, what I didn't show is that exception information is sent across the language boundaries. That doesn't mean, unfortunately, that you get the C++ stack trace in Android, but at least you get the exception message that gets passed along. And yeah, it's open source, so get it on GitHub if you want to try it out. And it's also used by a couple of companies already, big and small. And the demo code you can find at a GitHub repo of mine where I uploaded it before. So you can check that out right away. So with that, thank you all for coming. Happy to be here. And if you have any questions, come find me later, or now I'm here all week. So thank you.